Good morning, students. Now we see the next chapter, that is integral calculus. We already see the differential calculus. Now we see the integral calculus, where the integration is the antiderivative. We already see the differentiation concepts, whose reverse is nothing but integral. So what is the real life use of this integral? I'll give one example. Suppose one big thing you know very well, very big thing. Using the big thing to find the small thing in this purpose to use the integral calculus. I'll give one example. Suppose 100 gram of rice. Suppose 100 gram of rice, it contains 10,000 rice. For example, I say in 100 gram of rice, there will be, you count one by one rice. For example, I will take it is 10,000 rices. Then, according to 100 gram of rice is 10,000 rice. Then, what is the number of rices in 5 gram or 10 gram? What is the number of rices in 5 gram? So, one big 100 gram of rice, you know very well, 10,000. Using this 100 gram to find the 5 grams. So the big quantity to so small quantity to find. So in this purpose, the integration is useless. The differentiation is opposite. Small thing is known to find the big thing. The launching rocket, all the concepts are involving this differentiation, whose reverse concept is nothing but integral calculus. Okay, so big thing is known very well. Then to find the small thing in this purpose, integration is useless. I will give one more example. Suppose in your room or your house fully contains some molecules. Suppose you know very well the number of molecules in your particular room, in your study room or in your home. Then to find the number of molecules in some 1 square feet. So the total number of molecules, it is a crore molecule. You know very well. Suppose all the molecule is countable, you already. Then we find the number of molecule lies in some 1 square feet. Suppose we find in the 1 square feet, suppose 1 or 2 molecule will come in the square feet or will go in the other side of the square feet. So any one term is integrated, some constant is always lies. Okay, 100 gram of rice 10,000. Suppose 5 gram of rice is, suppose I say 100 rices only. Suppose you add one more rice, just to one more rice, the 5 gram cannot be changed. Just you put only one rice, or will be take one rice will take away. Then also the 5 gram of rice cannot be changed. So when we integrate anything, it should cause some constant. I'll give one example. It is a symbol of integration. Okay, actually the integration, capital I is enlarged. The I will be enlarged using the symbol is integration. So this is integration. Sin x into dx. How to read? The integrating of sin x with respect to x. We read integrating of sin x dx. That means integrating of sin x, okay, integrating of the sin x, where dx is nothing but with respect to x. You know very well what is the differentiating of sin x? The previous exercise. The differentiating of sin x is cos x. So it's also a formula. The integrating of a sin x is minus cos x. I already tell any one term is integrated, surely there will come one constant plus. So we integrate any term, we add a constant c. So it is infinite integral. Suppose some limits is in 1. The limit will come in your 12th standard. The limit will come, the constant c it cannot be occur because we integrate some limits. But here integrate is L large. So therefore, whenever we integrate any one term, the constant will occur. So the constant symbol is c. So integrating of sin x dx is equal to minus cos x plus c. So you must memorize the formula. I write the next all the formulas. I already tell integrating is nothing but anti-derivative. Integrating of sin x dx is equal to minus cos x plus c. How it is possible, sir? Is correct or not? We check. What is the answer? Minus cos x plus c. We differentiate that one. We differentiate the RHS. Exactly will come the LHS function sin x. Then our answer is correct. Now we check. What is the differentiating of this RHS with respect to x? We already know the differentiation concept. Now we are differentiating this RHS with respect to x. First of all, minus sign is there, so I put minus. The differentiating of cos x is minus sin x plus, where c is a constant. What is the differentiating of constant? The differentiating of constant is 0. So 0. So we leave. Minus and minus is plus sin x. You see exactly sin x will come. So an integration is nothing but antiderivative. It actually is a formula. Suppose we write is a exact correct formula or wrong formula, we check in this manner. So integration is nothing but the antiderivative. So what is the real life use of this integration? One big amount of thing you know very well. Then using this big amount of thing to find a small amount of thing. So in this case, the integration is uses. In the first exercise, I am using some formulas. So many formulas is there. At the time you write all the formulas, you confused. In the first exercise is the basic formulas. So I write 113 formulas. Okay, some important formula. The first one, integrating of dx. So we integrate one term and also a differentiation. We have the same thing. We already see one example. Integrating of differentiation of x is nothing but x. So integrating dx is just x plus c. Next one, integration of. So it is a simple integration. So you should memorize integrating of x power n is x power n plus 1 divided by n plus 1 plus c. It's not a differentiation. You know, in differentiation x power n formula is n x power n minus 1, but it is integration. So integrating of x power n is x power n plus 1 divided by n plus 1 plus c. So you should memorize integrating of x power n, but we write, when we write integrating of x power n into dx. That means integrating of this x power n with respect to x. Next one, integrating of e power x. Same, integrating of e power x is e power x. Integrating of 1 by x is log of modulus x. You write just log x also, but you write log modulus x plus c. Next one, integrating of sin x. Integrating of sin x is minus cos x. You don't confuse using differentiation and integration. Okay, now we see our integration. So it is the integration formula. At least you write 2 or 3 times in your class or note, also in rough note. Each and every formula should rise. So one time you must write all the formulas without seeing any materials. It is very useful in all the remaining x's also. So all the formulas are very, very important. So integrating of a sin x is minus cos x. So when we integrate any one term, I already tell one constant is there, so I put all the same plus c plus c plus c, where c indicates constant. Next one, integrating of cos x. Integrating of cos x is a sin x. And integrating of secant x tan x is a secant x. We see in differentiation, the differentiation of secant x is secant x tan x, but here reverse. Integrating of secant x tan x is secant x. Next one, integrating of cosecant x cot x is a minus cosecant x. We see in differentiation, the differentiation of cosecant x is minus cosecant x cot x is a reverse. The integrating of cosecant x cot x is minus cosecant x. Integrating of secant square x is a tan x. In differentiation, the differentiating of tan x is secant square x. But here, the integrating of secant square x is tan x. Next one. Integrating of cosecant square x is a minus cot x. In differentiation, the differentiating of cot x is a minus cosecant square x. So here, integrating of cosecant square x is a minus cot x. Next, a power x. It's not a e power x, it is a power x. So the integrating a power x is a power x divided by log a. A power x divided by log a plus c. Next one. Integrating of 1 divided by square root of 1 minus x square. We see this term in differentiation. Yes, it is exactly the differentiating of a sine inverse of x. Now the integrating of 1 divided by square root of 1 minus x square is sine inverse of x plus c. Next, the integrating of 1 divided by 1 plus x square is a tan inverse of x plus c. So in the first exercise, so this 13th formula is memorized, is must. So we use 1 by 1 formula or any one other formula in any one of the sum. You ask the question yourself, what is the differentiation of sin x? Is cos x. What is the integrating of sin x? Integrating of sin x is a minus cos x. What is the differentiating of a secant x? The differentiating of secant x is secant x tan x. What is the integrating of secant x tan x? Is secant x. So you don't confuse differentiation and integration. Now we see our integration. So you should memorize first of all these 13 formulas. Now we see some problems. In exercise 11.1, the first one, integrate the following with respect to x. So the question will be asked in two manner, either in word, okay, integrate the following with respect to x, some sums, or in another word, so you evaluate. The same question will be asked, evaluate. For example, the first one, integrating of x power 11 into dx. So the question will be asked in two manner, either in word, integrate the following with respect to x, or just evaluate. How to read? Integrating of x power 11 into dx. So in these two types, whenever you will be taking the question, actually it is a simple form, it is a word. Now we find the integrate of all sums. There will be 4 solutions are given. Just allow one word. So first we go to easy sum, difficult problem, but it is very easy. Now we integrate all the sums with respect to x. The first one, integrating of x power 11 into dx. So integrating of this x power 11 with respect to x, that means dx. What is the formula used? We already write the formula where x is a variable and power 11 is a constant. So using the formula of x power n. In integration, x power n formula is x power n plus 1 divided by n plus 1. Here what is the value of n? The power 11 is the value of n. You consider 11 is nothing but n. So x power 11. So x power 11 formula is x power 11 plus 1 divided by 11 plus 1 plus c. Now using the formula is x power n. Here in place of n, 11 is there. So x power 11 plus 1 divided by 11 plus 1. So x power 12 divided by 12 plus c. 11 plus 1, 2. So here also 11 plus 1 is 2. First subdivision over. Now the second subdivision. The given is integrating of 1 divided by x power 7 into dx. You see the x power 7 lies in denominator. But we use x power n formula, the x power n term lies in numerator. But here x power 7 lies in denominator. Suppose the term goes to numerator, x power 7 become, already the denominator term suppose goes to numerator, there will be a sign change in the power. So it becomes x power minus 7. So x power 7 goes to numerator, it becomes x power minus 7. Now using the same formula. Now it is of the form x power n. Now here what is the value of n? The value of n is minus 7. So So x power minus 7 plus 1 divided by minus 7 plus 1 plus c. Using the same formula, x power n plus 1. The value of n is minus 7, so x power n plus 1 divided by n plus 1. X power minus 7 plus 1 is a minus 6 divided by minus 6 plus c. Minus 7 plus 1 is minus 6. Again, there will be a minus sign in the numerator. So the term x power minus 6 suppose comes in denominator, it become x power 6. So in standard form this minus we write in numerator also. So minus 1 divided by 6 into x power 6 plus c. Now x power minus 6 comes in denominator, it becomes x power 6. Already 6 is there. In standard form the minus sign I write in numerator. So minus 1 divided by 6 x power 6. Now in third one, the given one is integrating of, how to read the limit, how to read the term, cubed root of x power 4. Okay, 3 is there. The number 3 lies within this root symbol. So cubed root of x power 4 into dx. First we write this cubed root of x power 4 in power term. How to write the cubed root? We write in cubed root as, what is the term first of all? X power 4. Cubed root is there, so we write it is 1 by 3. Suppose fourth root is there, we write 1 by 4. 5 is there, we write 1 by 5. Just the square root is there, we write it is 1 by 2. So x power 4 whole power 1 by 3. Now we multiply this two terms. What is the value of 4 into 1 by 3? 4 into 1 by 3 is nothing but 4 by 3. So integrating of x power 4 by 3 into dx. Okay, x power 4 into 1 by 3 is nothing but 4 by 3. Now using the same formula, you consider base is variable x. Power 4 by 3 is a constant, we treated it is n. So x power n formula. So x power 4 by 3 plus 1 divided by 4 by 3 plus 1 plus c. Using the same formula of x power n. X power n plus 1 divided by n plus 1. X power, what is the answer of 4 by 3 plus 1? One fraction whole number is there. We cross multiply. 3 ones are 3. 4 plus 3, 7. So 7 by 3 divided by same 7 by 3 plus c. But in standard form, in denominator there is a fraction. So this 3 goes to numerator. So it becomes 3 x power 7 by 3 by 7 plus c. So this 3 goes to numerator. 3 into x power 7 by 3 divided by the 7 plus c. Now we see in the fourth one. Integrating of x power 5 whole power 1 by 8 into dx. You see it is also same as the previous third one. X power 5 whole power 1 by 8. We write x power 5 whole power 1 by 8 as x power 5 by 8. Okay. We multiply these two powers. 5 power 1 by 8 is 5 by 8. Integrating of x power 5 by 8 using same x power n formula. So x power 5 by 8 plus 1 divided by 5 by 8 plus 1 plus c. Using same formula of x power n. X power fraction whole number cross multiply. 1 is 8 plus 5 is 13. 13 by 8 divided by denominator is also same. 13 by 8 plus c. But in standard form this 8 goes to numerator. So it becomes 8 x power 13 by 8 divided by 13 plus c. So this 8 goes numerator. So 8 x power 13 by 8 already is there. Divided by this 13 is there. 13 plus c. Now we go to the second one. Same. We integrate all the term with respect to x. This is the question. Okay, now we see the first one by one. In first subdivision is given 1 by sine square x. So integrating of 1 by sine square x into dx. You see directly there is no formula. But we using the trigonometry identities, we come one formula shape. We don't write 1 by sine square x a formula in integration. But you know very well in trigonometry 1 by sine x is nothing but cosecant x. So 1 by sine square x is nothing but cosecant square x. Okay, 1 by sine square x is nothing but cosecant square x. Now we see exactly the formula of integrating of cosecant square x is, we write the formula. The integrating of cosecant square x is minus cot x. So the integrating of 1 by sine square x is nothing but minus cot x. Now in all the four subdivisions, directly there is no formula, but we using the trigonometry identities, we come one formula shape. So first one integrating is a minus cot x. Now the second one, integrating of tan x by cos x. Tan x by cos x. Here also you see directly there is no formula. But we change, we modify one term, the exact one formula will come. So I write tan x by cos x as 1 by cos x into tan x. I write tan x by cos x as in this manner. 1 by cos x into tan x. We multiply these two, we get 1 into tan x by cos x. What is the reason, sir? What is the reason to exact write in this way? 1 by cos is nothing but secant. Okay, in trigonometry 1 by cos is nothing but exactly secant. We integrating of 1 by cos x is secant x. Already tan x is there into dx. Now you see exactly one formulation. The integrating of secant x tan x is secant x. So secant x plus c. So whenever we integrate any one term, one constant is lies. So I put in all the term, we add a constant c. So integrating of secant x tan x is secant x plus c. Now the third one. What is the given? Cos x divided by sine square x. Integrating of cos x divided by sine square x is a given. Now you have any idea? We already see the two sums. The third one. Directly there is no integration formula of this term. But we change using trigonometry identity, become one formula shape. So first you memorize the formula first of all. So if you memorize already the formula, we have some ideas. Cos x by sine square x. So how to write? I write cos x by sine square x as 1 by sine x. I split the sine square x as sine x into sine x. I write 1 sine x into cos x by sine x. So you check it is possible. We multiply the numerator, 1 into cos x is cos x. Denominator sin x into sin x is sin square x. What is the reason exactly to write in this way, sir? We know 1 by sin is cosecant. Cos by sin is cot. Integrating of cosecant x cot x. That is one formula. So I write cos x by sin square x as in this way. Integrating of 1 by sin x cosecant x. Cos x by sin x cot x into dx. The integrating of cosecant x into cot x is minus cosecant x plus c. So minus cosecant x plus c. Subdivision 4. 1 by cos square x. Here also there is direct formula is not there, but we change one formula shape will come. 1 by cos is nothing but secant. So 1 by cos square x is nothing but secant square x. The integrating of secant square x is tan x. So the answer is tan x plus c. Now the third one, there will be 3 subdivisions there. 12 cube or 12 power 3. X power 24 divided by x power 25. And the third one is e power x. So there will be 3 sums. Allow using the same way, integrate the term with respect to x. Okay, the first one, integrating of 12 power 3 into dx. Now we are using x power n formula here. So we don't use x power n formula because the base 12 is not a variable, it is a constant. By urgently, suppose we write it is 12 power 3 plus 1 divided by 3 plus 1 is entirely wrong. Now 12 power 3, where power is a constant and the base is also a constant. Suppose a constant is multiple with a variable, the first step, so will be take outside the constant of this integration. So 12 cube into integrating of dx. It's important. 12 power 3, both are is a constant. So using x power n formula, when we use this formula, base is a variable and power is a constant. But here both are constant. So when integrating, some constant is lies with this variable. So we will take outside the constant. So 12 power 3 into integrating of dx. So 12 power 3, we already say integrating of dx is exactly one formula, x plus c. So the formula of integrating dx is x plus c. So 12 power 3 into x plus c. Next one. Second one, integrating of x power 24 divided by x power 25 into dx. X power 24 divided by x power 25. The simplification is possible here. X power 24 by x power 25 is fully cancelled. 25, 1x is remaining. So 1 by x into dx. The integrating of 1 by x is log of modulus x plus c. So this simplification idea will come yourself only. Or this term is, suppose I go to numerator, okay, x power minus 24. Then x inverse is there, we write x inverse as 1 by x. And the third one is a direct formula. The given one is e power x. So just only one. What is the integrating of e power x? The integrating of e power x is the same, e power x. So e power x plus c. Okay, the fourth one, we integrate these two terms. Okay, the first one, integrating of 1 plus x square the whole inverse into dx. How to write 1 plus x square the whole inverse? We write this one is integrating of 1 divided by 1 plus x square into dx. We write 1 plus x square the whole inverse as 1 divided by 1 plus x square. The integrating of 1 divided by 1 plus x square is tan inverse of x plus c. So now we come to exact one formula. So 1 by 1 plus x square is a tan inverse of x. The second one, integrating of 1 minus x square whole power minus 1 by 2 into dx. You see the power minus 1 by 2. First of all, I take the power minus 1 by 2 term comes in denominator. So it becomes 1 divided by 1 minus x square whole power 1 by 2 into dx. The power minus 1 by 2 comes in denominator, become whole power 1 by 2. You know, already in lowest class, we write 1 by 2 in power. How to write? We write the power 1 by 2 is we write it is square root of 1 minus x square. So integrating of 1 divided by square root of 1 minus x square is exact formula, that is sine inverse of x. So sine inverse of x plus sc. So we see fully the first axis. So first axis is over. Now the same model regarding sums is lies in the example. So you try. First of all, the 13 formula, you must memorize all this formula. The formula is very well. Then every problem you should derive easily. Suppose you don't have any formula, then you don't have this idea. Suppose this term is given, then the formula will click. So first you memorize the formula and you try the regarding example sums.